We now discuss the solution of a problem from the section Mathematical Reasoning. This question is based on the concept of tautology. This question has appeared in the joint entrance examination main held on 26th June 2022 in the first shift. The given question is, let delta del belongs to the logical connectives and R be such that P del Q implies in brackets P delta Q then delta R is a tautology. Then P del Q delta R is logically equivalent to, we are given four options. Option A, P delta R R Q. Option B, P delta R and Q. Option C, P and R delta Q. Option D, P del R and Q. And we are given two symbols, delta and del belongs to the set of logical connectives containing and R be such that P del Q implies P delta Q del R is a tautology required to find P del Q delta R logically equivalent to one of the following four options. We now discuss the solution of the problem in detail. We are given two symbols, delta del belongs to the set of two logical connectives and R, and P del Q implies P delta Q delta R is a tautology, and this Boolean expression is equivalent to, we use this one, P implies Q is logically equivalent to negation of P or Q. So we apply here. So P del Q implies P delta Q del R is logically equivalent to the negation of the first, that is P delta Q R, the second, that is P delta Q del R. P del Q R P delta Q del R. So instead of this one, we take this and test for tautology for what truth values, for what logical connectives this delta and del in this is a tautology. So we deal with four cases. Case 1, in which delta we have taken R, del, and then the above Boolean expression 1 now becomes, so del is R, del is and, right? This R, don't touch it because that has come in a logical equivalence. And P delta is R Q, del R, del is and R. So this is the Boolean expression 1 in when delta is R, del is and. Now this is not a tautology. How do we show? Suppose let PQR take the truth values true, true, false. Then what happens to the Boolean expression 1? So go inside and T, RT is T and F. T and F is F. So union F, and P is T and T is T. Negation of T is F. F or F is F. So the Boolean expression 1 becomes false. That means it is not a tautology. Agreed. 2. Now let delta be and del be R. Then this Boolean expression 1 now becomes negation of P del. Del is R Q R. P delta. Delta is and Q. Del R. Del is R. So R R. So now suppose P Q R take the truth values respectively F, T, F. Then what happens? Now R. R is F. F R. F and T is F. F or F is F. R. P is F. R. T. So P, that is F R T is T. Negation of T is F. F or F is F. So the Boolean expression 1 takes the truth value F. Therefore, it is not a tautology. Now the third case, where we take delta is N and del is R, then the Boolean expression 1 becomes this way. Then take the truth values for P, Q, R respectively T, T, F. Then R is F, P and Q. P and Q. T and T is T. T and F is F. R. P and Q. T and T is T. Negation of T is F. F or F is F. So Boolean expression 1 takes the truth value F. Therefore, it is not a tautology. What is a tautology? For all truth values of P, Q, R, it should be true. And for a particular choice of the truth values of P, Q, R, it is taking the truth value F. Therefore, it is not a tautology. Now, obviously, the fourth option, the fourth case will be a tautology. So, delta is R, del is also R. Then the above expression 1 will be yes, it is a tautology. How it is, we will show you in the next slide. Case 4. Let delta is equal to del is equal to R. Then the given expression is logically equivalent to negation of P del Q or P delta Q del R. That is the Boolean expression 1 which we have already considered. Now this is equal to, yes, I am not writing logically equivalent to, equal to. Why? Because for delta and del, wherever they are appearing, we write R. So we write R here. Now we use the associativity. The associativity, these are the two components, and this is the third component outside. The associativity we use, and that is negation of P or Q or P or Q in brackets or R. This is always a tautology, and this always takes T. And negation of P or P is a tautology, is identical equal to T for all values of T. Therefore, logically equivalent to T or R. And for any truth value of R, T or R is T only. T or P is logically equivalent to T. So it is T. So for all values of truth values of P, Q, R, it takes the truth value T. Therefore, it is a tautology. Yes, it is a tautology, and now required to find the what is this Boolean expression. This is P del Q delta R, and del is R, delta is also R. P R Q R R, and this is logically equivalent to P R Q R R. You are using associativity. But now we use commutativity for Q or R, then this becomes R or Q. Why are we doing this? You see, we look at our options and trying to bring into that form. Commutative law we have applied. Now use the associativity again. So is logically equivalent to P or R or Q. Now this is logically equivalent to, just replace R by delta just to meet one of the options there. So this is logically equivalent to P delta R R Q. This we have written just to meet these options. Now suppose we take the earlier step. P R R R Q is there. It is not there in this. But you see, del is equal to delta is equal to R, logical connective R. So therefore, replace R by delta just to meet this option. So the option A. So therefore, this expression is logically equivalent to this one, which is the option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the problem from the section mathematical reasoning based on the concepts of tautology. Great. I wish you all the best. Thank you.